Hello, my name is Emily Ireland and this is my Lab 4 over oscillations. The purpose of this lab is to examine the motion of an object swinging in an arc while oscillating on a spring. I'll use Newton's second law and the energy principle to help explain the motion and characteristics of the moving object. The predicted results of the experiment are that delta E will be around 0. However, the experimental results will vary slightly because the experiment is not perfect. Some important info. As you can see, F net equals the change in momentum divided by the change in time. The velocity update formula says that the final velocity equals the initial velocity plus F net divided by the mass times delta T. And the position update formula says that the final position equals the initial position plus average velocity times delta T. Here it says the change in the energy of the system equals the work in the surroundings plus the heat of the surroundings. Then we can say that the change in energy of the system equals the change in kinetic energy plus the change in gravitational potential energy plus the change in potential spring energy. K equals 1/2 mv squared, U spring equals 1/2 ks squared, where S equals L minus L naught, and U grav equals mgh. Since we are putting nothing in our surroundings, that means that W surroundings will be 0 and Q surroundings will be 0, and delta E will also equal 0. The forces in the experiment are gravity and spring, and both of those combined make the F net. Here's the tracker video. I chose up as the positive Y direction and right as the positive X direction. Here are the initial conditions for glow script. It was given that the mass is 0.402, and I used tracker to find the initial position and set the initial velocity equal to 0. G is 9.8, and using these formulas I found that K equals 6.87 and L naught is 1.27 meters, and put that into glow script. I also used the formula from the previous slide to update L, L hat, and S, as well as K, U, G, U, S, and E. Now for the calculation loop, I updated all of these formulas according to the formulas from the formula slide a few slides ago. Then I set all of the delta K, delta UG, delta US, and delta E to be the final minus the initial of each of the corresponding variables. This is the resulting computational graph. All of the energies except for the change in total energy oscillate up and down. However, as you can see, the total change in energy is a straight line, which is at 0. And this is the experimental versus the computational graph. They're not completely lined up, but they are pretty close, meaning that the model and the experiment are pretty accurate. So some potential sources of error. There could have been some calculation errors. Plus, this is a non-perfect experiment as we saw on the slide previously, so outside forces affect the video. Also, the tracker calibration could be off, and I could have misclicked during the recording of position on tracker. So, for the ending questions, is the energy principle satisfied? We know that delta E equals the work from the surroundings, and since there was nothing in the surroundings, it equals 0. And we found in the experiment, as you saw in the graph, that the total change in energy is 0, and therefore the energy principle is satisfied because these two quantities are equal to each other. And for the estimations of oscillation periods, the T from the X position that I calculated was 1.61 seconds, and the T from the Y position was 1.52 seconds. This results the effect of the experiment because T was used to calculate K and L naught, which are important to finding the change in energy because they affect the spring potential energy.